Welcome to the DIY Honda Garage channel. The DTC U1282 indicates a communication failure between the passenger's multi-information control unit, MICU, and the driver's MICU in the Honda Accord model years 2008 to 2012. The MICU is a crucial component within the vehicle's body control module system, responsible for various functions such as lighting, security systems, and power windows. The passenger's MICU is typically located under the dashboard on the passenger side, while the driver's MICU is placed similarly on the driver's side. When communication between these two units is interrupted, it can lead to various operational issues and can set off the DTC U1282. The importance of resolving this error is highlighted by the role of these units in maintaining the functionality of multiple systems, ensuring that the vehicle operates smoothly. In the context of DTC U1282, the passenger's MICU primarily serves as a communication hub for various electrical systems in the passenger compartment, managing features such as lighting and door lock operations. The driver's MICU performs similar functions on the other side of the vehicle, but also interfaces more directly with critical driving controls, like the ignition and windshield wipers. Both units communicate over a body control area network, BCAN, facilitating data exchange to coordinate operations. The passenger's MICU is typically located beneath the dashboard on the passenger side, where it can access necessary wiring harnesses. The driver's MICU is situated in a comparable location, but toward the driver's side. Failure in this communication could lead to disabling critical vehicle functions, making it imperative to diagnose and resolve the underlying issue promptly. Several possible causes can trigger DTC U1282. One of the most prominent is a faulty passenger's multi-information control unit, MICU, which may not be able to send or receive signals effectively. This could require replacing the unit to restore communication. Loose connections are another potential culprit. If the wiring between the passenger's and driver's MICU is not secure, it can disrupt the BCAN's effectiveness. Additionally, there can be intermittent failures that do not present themselves consistently, making diagnosis challenging. Addressing these symptoms promptly allows for a more effective resolution, ultimately safeguarding against further electrical issues down the line. When DTC U1282 appears, a variety of symptoms may manifest in the vehicle's performance. Electrical systems may start malfunctioning, leading to features such as lights not functioning correctly or windows failing to operate. Users may also notice inconsistent behavior from various controls, making it difficult to predict which systems will work at any given moment. This erratic functionality often results in a cascade of faults, risking inconvenience and safety. Additionally, dashboard warning lights may activate, alerting the driver to potential issues with the electrical system, thereby increasing driver concern. Recognizing and addressing these symptoms is crucial for restoring normal vehicle performance. The first step in troubleshooting DTC U1282 is to clear the diagnostic trouble codes, DTCs, using the Honda Diagnostic System, HDS. This tool allows technicians to erase existing codes, resetting the vehicle's computer, and ensuring a clean slate for further diagnostics. It's crucial to perform this action because lingering codes can cloud the diagnostic process and lead to misdiagnosis of issues. Clearing DTCs prepares the vehicle's system to run a fresh self-check upon restarting, making it easier to identify new or recurrent errors. Be sure to connect the HDS properly and follow the prompts to ensure that all codes are cleared effectively. After clearing, The next diagnostic steps can be undertaken with a clearer understanding of the current system state. After clearing the DTCs, the next troubleshooting step involves turning the ignition switch to the lock 0 position and then back to the on 2 position. This process reinitializes the vehicle's electronic systems and prompts the onboard computer to perform necessary checks. It is essential in ensuring that all systems are powered up and that any live connections are re-established. During this process, users should allow at least a few moments before proceeding, typically waiting about 6 seconds. This pause permits the systems to fully initialize, leading to more accurate diagnostic results. Following this step correctly is vital for the next phase in verifying the presence of DTCs and the functionality of the communication link between MICUs. In the third troubleshooting step for DTC U1282, it is important to wait for at least 6 seconds after switching the ignition back to on. Second, this waiting period allows the onboard vehicle systems adequate time to initialize and establish all necessary communications. Swiftly moving on to the next checks without this pause can result in incomplete system readiness, which could yield misleading results in subsequent diagnostics. This waiting period significantly helps by ensuring that all electrical modules are functioning as intended. Once the 6 seconds are complete, the technician can confidently check for any DTCs using the HDS, knowing that the systems have been properly initialized. This attention to detail is essential for high-quality diagnostics. The final troubleshooting step involves checking for DTCs using the Honda Diagnostic System, HDS, after the ignition has been turned on and at least 6 seconds have elapsed. This action is critical in diagnosing whether DTC U1282 is still present. By utilizing the HDS, technicians can retrieve any active codes stored in the vehicle's system, providing a clear view of any remaining issues. If DTC U1282 appears again, it indicates a persistent fault, likely in the passenger's MICU or related wiring. However, should the code not reappear, this may imply that the previous issue was temporary or intermittent. Understanding what these results mean will guide further actions, either replacement of faulty components or merely securing any loose connections for enhanced reliability. Upon completing the troubleshooting and any necessary repairs for DTC U1282, it's essential to conduct a final repair verification to ensure everything is functioning correctly. This includes retesting all relevant electrical systems to confirm that they operate as expected without any glitches. Technicians should also check that all connections are secure, confirming that the issues experienced have been resolved. After the tests, performing another scan with the HDS can help ensure that no DTCs are currently present. If all systems are operational and no DTCs reappear, then the repair can be deemed successful. This verification step is crucial, not just for confirming repairs, but also for ensuring the safety and reliability of the vehicle moving forward. Preventive maintenance is essential for avoiding future occurrences of DTC U1282 and ensuring the longevity of the vehicle's electrical system. Regular system checks can be scheduled to ensure that both the passengers and drivers' MICUs are functioning as intended and that they are communicating effectively over the Body Control Area Network, BCAN. Additionally, it's advisable to periodically inspect wiring connections for any signs of wear, corrosion, or looseness, as these factors can lead to communication failures. Implementing these maintenance practices can be simple but effective steps in safeguarding against potential issues. Educating vehicle owners about the importance of these checks enhances their understanding, and promotes proactive vehicle care. Ultimately, this fosters a smoother and safer driving experience for all. In conclusion, understanding the roles of the Multi-Information Control Units, MICUs, and recognizing symptoms related to DTC U1282 are critical for effective vehicle maintenance and repair. Technical knowledge of these systems facilitates a swift identification of issues, enabling timely interventions that can prevent further complications. Conducting thorough troubleshooting steps, as outlined, ensures that both systematic checks and component replacements are performed accurately. Ultimately, effective communication among vehicle components is vital for maintaining operational efficiency. With appropriate preventive maintenance, future instances of trouble can be minimized, contributing to a more reliable and enjoyable vehicle experience. For owners of the Honda Accord, adhering to these practices not only fosters vehicle longevity, but also enhances overall safety. Please like and subscribe to the channel. See you next time.